Good morning, and we're looking at underlying cause of death database on Wonder at the CDC, looking at the 1999 through 2019, still 2019 numbers, though I'm also going to be looking at previous years. So there's different age groups we can look at, and I'm just going to look at age groups, not single year ages in this video. I'll do single year ages in the next video. Let's start with 10-year age groups, and I will be looking at both 10-year age groups and 5-year age groups. Let's do 10-year age groups and year. And one of the things we're going to do with these data polls is check the numbers against different aggregation groups and make sure that they add up to the same numbers. We're also going to try a few things that are not going to work, and I'll show you why. I don't like having the total rows, so go back to the quick options. We're going to hide the total rows before we export. And it's not a big deal. So we're going to export the table looking like this. So I aggregated by the age groups and then by the year. Of course, when we get into Excel, we could always resort it the way we want. So pop open. As I said, this is not the best practice, but it's how I do it. Now, one of the things I want to point out to you when I copy pasted into Excel for these 10-year age groups, what happened to to some of the age groups? You'll notice, and let me just do this to word wrap. Okay. So we have our 10-year age groups and then the code. And the code is like numbers 1, and then this was 1-4, which Excel helpfully converts to the date January 4th and then the year we're currently in, 2021. If I did it in the next year, it would say January 4th, 2022. Thank you, Excel, for interpreting numbers 1-4 as a date, even though I didn't ask you to. Let's see if I did it best practice that Excel will do it the way I want to do it. So I'm going to go into File, Open. This is going to be in my downloads, so I'm going to browse to downloads. Okay. I'm going to not do all Excel files, but all files. So it shows up. Here's our underlying cause of death, and I'll just say open. See what it does. Okay, it's going to allow for delimited. Okay. It did notice that it's tab delimited, which is correct. Now let's change the formatting on everything. This is general, and general means that it's going to interpret this the way it wants to. So I am not happy with how it did that. I'm going to force things. I hate general. It's either going to be text, date, and general means it's going to interpret the numbers it wants to. Now for year, I'm going to let it interpret it as numbers. These are numbers. I'll keep them as general. And the rates are also numbers. So if it's a number, I'm going to let it flow through as general. But for these age groups, I'm going to make it text. So let me finish and see if it does it correctly. Let's see, is it January 4th? No, it's 1-4. Yay. You'll notice there's this little green thing in the corner, and that means it notices it's a numeral 1 and it's stored as text. And I'm like, no, that's what I want. Ignore error. And I can do that for all of them as, together as a block. Ignore error. Let's see if any more they go. And none of these are, so not stated as NS. And I am very happy with that. We're going to go with this one. You guys are gone because you suck. And this is why you follow best practices and don't listen to me and just copy paste. Okay, what I really do, because there's 2 columns, I just ignore the one that gets changed into dates and I use the one that is obviously text. But this is the 10-year age groups. Let's do the same thing for 5-year age groups. I'm going to go back here, go back to my request form, and change that 10-year age groups to 5-year age groups. And let's send. And let's take a look at those. These are actually subsets of the 10 years we have. We don't want the totals again, so let's hide total rows. No, I don't think there is a way that you can set up your defaults for pulling data that it won't show the totals before you do it, but maybe there is. I just don't care because I can easily remove the totals before. So remember, let's import it properly. Okay, I'm going to open it from, and this is, I think, the best way, from my downloads. And it's number 7. You can see I've been doing this a lot. And okay, I guess best practice would also be to name my queries so I know them apart. But I know, okay, oh, my data has headers. Ooh, actually, I don't want to do that because it's going to, if I say my data has headers, it's going to do something specifically, and I don't want to do that. Okay, so I'm fine with that. But again, I don't want these to be general. This is text, and this is text. And now I'm fine. And I'm going to move this one. This is 5-year age groups. And then I'm going to move this one, move or copy to the other one. Okay, move to end. And I actually need to save this properly. Save as. I'm going to browse to my mortality folder. Everyone should have a mortality folder. And remember, I just want to tell them, nah, I meant to do this. Ignore error. That's best practice. Okay, so now we actually want to check that the numbers are adding up properly for the subgroups. This is not a data audit per se. This ties into ASOP 23, Actuarial Standard of Practice 23, which is on data quality. So as an actuary, first off, I do trust this data. I've had people, leave comments, blah, blah, blah. It's difficult to falsify data the way people are saying. It is very difficult to make it work, as people are finding out. So I'm going to show you a very simplified way. I'm not doing all the lookups that I would normally do. I'm going to cut for a moment and then put down what the 10-year age groups are so you can see how I would check. Okay, I totally lied in terms of I am doing lookups. I'm not going to spend a lot of time explaining them. I will share the spreadsheet. I'll put it on my Dropbox and put a link to the spreadsheet in the Dropbox in the video description on YouTube. And if you're reading my blog, I'll give a link, or if it's on the Substack, I'll just drop the spreadsheet within the Substack post. Isn't that nifty? So let me start with the easy one. There is in current version of Excel 365, a function called unique, and it is an array function. You say equals unique, and then, you go down an array. So I went to the 10-year age groups, and I went to the one that's definitely text, this one here, not the one with the number codes that sometimes go to dates. And I had it go down here, and what it will return is a vector of the unique values that are in that column. Now I did the same thing across here, but I also included the array function transpose so that instead of a column, I get a row. Okay, so then I used XLOOKUP. I had to add a column, and you'll see it here over in the yellow. This is the lookup key. Let me put a space there so you can actually see it. And let me do word wrap on this so you can see these and make them bold so you can see them even better. Um, so I added a key because how do we look up our values? We are getting our data in our export. The way you extract it from the database is proper. You could say it's in tidy form. It's a flat file form that you can do. But when we do our graphs, we're going to need a grid like this. So I'm going to be actually doing some graphs of the deaths by year and by age group in a post. That's actually why I'm pulling this, because I'm going to fix a graph from the New York Times, and I needed this data historically, and then I'm going to add the 2020 data that I have. Um, in any case, uh, so I need the age group, and then I need the year. So that will be the unique identifier, and then I'm going to find the deaths. So with XLOOKUP, I'm trying to find the row in which this specific lookup key is. And I have it set up, if you know anchors, and again, I'm not spending a lot of time explaining Excel here. This dollar sign is an anchor in the way Excel, and this is really what gave Excel or spreadsheets their power, is the way formulas work with relative versus absolute references. And you know what? Maybe I'll do some Excel, a few Excel, lookup videos later because lookups, are very powerful. It's one of the things people do a lot with spreadsheets. I know actuaries do it a lot. Yes, it happens in databases as well, but actuaries don't like using databases as much because not only do we have to look up things, often it's not just we have to graph, but often we have to calculate things with the stuff we look up as well. And the databases tend not to, calculate. They're just there for aggregating data and, spitting out some numbers for us, not to do extra calculations on top of that. In any case, I'm anchoring that A, so I'm going to be pulling from this column, and then I'm anchoring this row 1, and I'm going to be pulling from this row. So I'm going to, and then the ampersand is a concatenation of text. And again, not going to really explain too much. So I'm going to look up this and this. That's going to be my key, and then find the number of deaths. So yeah, the infant mortality is a problem. Always has been. And part of that, well, there's all sorts of reasons for that. In any case, you can see most people are dying in the oldest age groups. Some of this has to do, of course, with mortality rates, but also, how many you have in a particular group. When I was talking to my grandmother, she died in 2017 and she was in that 85 plus group. But I was trying to explain to her why she was seeing obituaries of people, more obituaries of people, and this was like back here, of people 20 years younger than her. And it had to do with more and more boomers dying. So this would have been people in this bin. And so you're seeing that number going up and down. It's kind of interesting because it's not just mortality rate, which was going down, but the number of people in that bin. So I will graph that in a moment. But not right yet, because what we're going to do is compare this against our 5-year age groups to make sure things add up as they should. So I'll do the 5-year grid and then I'll show you how we're going to check it. Okay, so I've got my 5-year grid set up. Obviously, these are smaller bins, but you'll see that the years will add up, that 2 of these bins, and in some of the cases more, will fit in the 10-year grid. And I want to check that they actually add up to the same thing when I do the data draw. So I'm going to do the 10-year grid and then minus, I need to make sure it adds up to the same thing. So I'm going to go down to 1999. 1 to 4 is actually the same bin in both of them. 1 to 4 And then this is 1 to 4. Then I have 5 to 14. So this is 5 to 14. And I need to check 5 to 9 and 10 to 14. Is that going to do it? Yep. So then 15 to 24. Actually, best practice would be to do some instead of both of them, 15 to 24, and so on. Yes, 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 yes. And I'll continue doing this. Okay, so I took the difference over each bin, and then I took the sum over all of them. Now, different things one could check is actually putting the absolute value around each of these. So let me just copy this, put this. Yeah, that's, sorry about that. Let's just do this and that and make this the absolute value of each of these. So this gets copied to there, this gets copied to there, and then this gets copied to there. Okay. Unsurprisingly, these all match up. The way these age groups are combined, this is hardly surprising. In a future video, I'll be doing the single ages, and obviously the age groups are made combining each of these single age groups by, and then just add up the number of deaths. Easy. So let me make some graphs and then come back to you, and then you can take a look. I'll just do the 10-year grid, 5-year grid, who cares? There will be too many items in the graph for you to look at. So here's the graph. This is just number of deaths. I'm not doing the crude death rate for each of these groups. Obviously, 85 plus years still, the predominant age group where you're seeing deaths, but you're seeing an increasing number of deaths from the younger age groups, 55 to 64 and 65 to 74. And that's, of course, due to the aging of the baby boomers. Think of, okay, once the oldest were born in 1946. When did they turn 60? 2006. So they're 60 here. And, so then when are they 65? 2011. Boom, 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 boom. And you're starting to see it grow. It's really, you're going to see this tsunami of the boomer deaths. The silent generation before them were like kind of a baby bust, depression babies. There were fewer births during the Great Depression. I'm through a baby bust myself. I'm Gen X. We're not going to spend a lot of time talking about these mortality trends, but let me show you one more graph. So here we have percentage composition of deaths. It's hard to see, because, you're trying to eyeball it. 85 plus, still, you kind of see a growing percentage for the 85 plus. And, part of this is a growing population in the 85 plus range. But you do see the 65 to 74. So you have the silent generation moving through some of these older years. And then you see the boomers coming into the 65 to 74. So you can kind of see where these percentages are going, and obviously below age 55, it's minimal in terms of death rates and death numbers. So this is kind of interesting. We can push this back to earlier dates. If you go back to Wonder, so if you go to the first landing page and you're going to the underlying cause of death, instead of 1999 to 2019, you can pick 1968 to 2016 compressed mortality. Okay, we don't want the 1999, but maybe we want 1979 to 1998 to get the 20 years before that. And let's say we want age group. Now we notice you don't get to choose 10-year age group versus 5-year, and we want it by year. There are fewer things you can aggregate by in the older one. Let's Still want to suppress the totals. Going to export. So notice, and this is the default name, compressed mortality 1979 to 1998. I'm going to do the bad thing because I'm just being lazy. So unfortunately, you kind of get a weird mix of the 5-year and the 10-year. So when I have two data sets that don't mesh like this, they have different year groupings and that kind of thing. What I do is I do actually make a new lookup grid. So it looks like it doesn't match under age 25. So what we can do is we're going to insert like 20 years just to indicate. So the less than 1 year works and the 1 to 4 works. 5 to 14 needs to be a sum. 15 to 24 needs to be a sum. And I think it matches up after that. Okay. Seems to match up pretty well. Let me extend my graphs. So here we have our updated graph. It goes from 1979 to 2019. So 41 years of data. This is nice. We see the growing number of deaths in the 85 plus category. If we go to the percentage, we see the growing percentage of deaths in that 85 plus. And no, it's not because of increasing death rate, which I'm not going to show in this one. We'll look at that in a future video. It's because more people are living that long and we have more 80 old people to die in that category. So it's interesting to see these percentages change over time. It's kind of cool. Anyway, enjoy playing with the database.